Okay, hello again, everybody, and welcome to today's lesson. Today's notes, we're going to talk about part 3 of 9.5. Back in part 2 last week, what we did was I told you we were going to solve a classic type of algebra problem a different way, but we had to learn to do something first. So last week in part 2, what we did was we learned how to find the determinant of a 2 by 2 matrix. So we're going to use what we learned last week, that simple tool, that simple application, and we're gonna take that and apply it to solve a system of equations using that information that we learned. Okay, so let's go ahead and look at what we got. So here in part 3 today, what we're going to be doing is we're going to be solving a system of equations by using the determinant of a matrix, and this is called Cramer's rule. The directions in your problems for homework you're going to do, it says use Cramer's rule. That's what we're going to learn in the notes today, okay? Now remember, 2 by 2 matrix is simply something like this, where you have 4 numbers in here, 2 by 2, 2 rows and 2 columns, okay? Let's quickly review on how to find the determinant, all right? Remember, the determinant is when you multiply these two numbers, 5 times -2, and you subtract the product of these two, -7 times 3. And you just figure this out. 5 times -2 is -10. -7 times 3 is -21. And you subtract those. So -10 minus -21 is +11. So the determinant of that matrix would be +11, that number. You always get a number. Okay, so that's a quick review on how to find the determinant. Now remember, a system of equations is something like this. 2 xy equations, and normally they're in standard form like this. The ones you get today are in standard form, so they're simpler to deal with. You have x and y on one side, and a number called a constant on the other. Now remember, the numbers in front are called your coefficients. So your coefficients on x are 3 and 1. Your coefficients on y are -4 and +7. The numbers with no variables on the other sides are called your constants. So 10 and -14 are called your constants. This is one constant. This is another. 2 constants. All right? And remember, when you're told to solve a system, you're finding an x value and a y value. And that makes an ordered pair point where the lines would cross if they're graphed. Now, in algebra, you're taught to solve a system like this by either graphing the lines or using substitution method algebraically, or maybe using the elimination method, which is another algebraic method. We're not going to use any of those. We're going to use Cramer's rule with the determinant, which is strictly arithmetic. Multiply, subtract, make a fraction, divide, maybe simplify. No algebra or trigonometry or anything like that involved. All right? Now, this front page, we're going to look at the process, and then we'll do a couple examples on the back, all right? Now, when you're solving for the number for x and the number for y, you first start out making fractions for them, and sometimes the fractions simplify to whole numbers or integers, okay? So you might get fractions for your answer every once in a while when you do this, but most of the ones I give you that we do, you're going to get positive and negative whole numbers, okay? But you're going to form fractions to begin with. And remember, you have 2 numbers. So if you have 2 fractions to represent the 2 numbers, you're going to have 2 numerators and 2 denominators. Okay, so what you're going to do, the first thing you're going to do for all of these, you're going to see when we do the problems on the back, is since you need 2 numerators and 2 denominators to get your 2 numbers for x and y, 2 and 2 is 4. So you need 4 total numbers, okay? So you're going to be getting 4 total determinants. Each of these numbers for the 2 numerators and 2 denominators are going to be determinants that you figure out, which is doing what we did up here, real easy, okay? Now, a little more. The denominators, okay? The way you figure out the denominators for your x and y, they're both the same, is you do this right here. You figure out what the determinant value is, the normal determinant of the x and y coefficients. And we did this in 9.5 part 2, like I mentioned right here. So you get your xy coefficients, you find the determinant of those, and that is your denominator on each of your x and y, both of your denominators, your bottom numbers, okay? Now, the way you figure out the numerators, the 2 numerators, one for x, one for y, is you also calculate the determinant. It's almost the normal determinant of the x and y coefficients, just like we did for the denominators over here. But not quite. What you have to do, the x and y coefficients, that 2 by 2 matrix with the x and y coefficients like you've got over here for the denominators, what you do is for the x, when you're solving for x, you replace the x coefficients with both of your constants, with your constant numbers. Okay, so again, when you're solving for x, that 2 by 2 matrix you make, you replace the x coefficient numbers with the constant numbers. Okay, you keep your y coefficients the same. And when you go for your y numerator, the numerator for y, that number, that determinant, when you go for that one, you replace the y coefficients with the constants. In the 2 by 2 matrix, you keep your x coefficients the same when you're going for y. Right? And then you just find the determinant of each of those. And that will give you your numerator for each of your numbers. Right? And then what that will do, both of these will do, is it will give you 2 fractions, and you simplify each of them. And that's how you get your x and y values, and you have your xy coordinate point for your solution. All right, guys? I know all of this kind of doesn't make too much sense right now, but this is what we're going to follow on the back. All right, so here we go. Let's look at number 1. We're going to solve each system using Cramer's rule and determinants. All right, so, we look at the system. Here are your x coefficients, 12 and 2. Here are your y coefficients, positive 3, negative 3, right? And your constants are 15 and 13. All right? Now, first thing we're going to do is figure out our denominators. Your denominator is the same for each. All you do is the normal x and y coefficients, that determinant. So look, to find your denominator, which we'll do first for each of your x and y, is you do the normal 2 by 2 matrix, the determinant of that for your coefficients. So you make your 12, 2, 3, negative 3. And you find the determinant of that. So 12 times negative 3 minus 2 times 3. And you figure that out. So this is negative 36 minus 6, which is negative 42. So that number, negative 42, guys, is your denominator for your x and your denominator for your y. So over here, we know that our answer for x and y are both going to have a denominator of 42. So let's go ahead and put that as our denominator. We'll simplify later once we get our numerators. Now, we got the denominator for each. Now we're going to get our numerators, okay? Now, first we'll do x, and then we'll do y. All right, so it says that when you're going for x, okay, you replace the x coefficients with constants. So you're going to take the matrix you just got, the determinant of, but since you're going for x, you're going to replace your x coefficients with constants. You're going to keep your y's. So we make our little matrix. You keep your y's, but replace the x coefficients with constants. Your constants are 15 and 13. Okay? And now we find the determinant of that. So 15 times negative 3 is negative 45. And we subtract 13 times 3, which is what? 39. And negative 45 minus 39 is negative 84. So that is your numerator for x. So you put negative 84 over negative 42. And look at this, nice and easy. When you divide, you get positive 2. So it looks really messy with all these crazy numbers, but at the very end, when you simplify, you get positive 2. That is your x value. All right, for y, you go to your 2 by 2 matrix. But since you're going for y, you replace the y coefficients with your constants. So you use the x coefficients, 12 and 2, but in place of y, you put 15 and 13. Okay, and then you find the determinant of that. So you do 12 times 13, which is 156, and you subtract 2 times 15, which is 30. 156 minus 30 is 126, which is a bigger number, but when you put it over negative 42, because that's the numerator for y, and you divide this out, it gives you a nice negative 3. And there you go. You're pretty much done. X is 2, y is negative 3. Your last step, guys, is to write it as a coordinate pair, a point. So 2, negative 3 is your answer. All right, there you go. So we solved it with pure arithmetic, no algebra or graphing or trigonometry, any of that stuff. All right, just a handy little rule. Let's try it one more time. All right, so coefficients are 1 and 3 for x, 2 and negative 4 for y, and then 3 and 4 are going to be your constants, all right? First, let's do the normal xy coefficient determinant for our denominators. So 1, 3, 2, negative 4. That determinant's going to be 1 times negative 4 minus 3 times 2. That is negative 4 minus 6, which is negative 10. So that is your denominator for each of them. All right, so we can do x is going to equal something over negative 10, and y is going to be something over negative 10. All right, we got to find the numerators now. So here we go. Let's do x first. So for x, you're going to take the same 2 by 2 matrix, but in place of your x coefficients, you're going to put your constants 3 and 4. So 3 and 4 go in place of 1 and 3, your x coefficients, and you keep your y, 2 and negative 4. And now you're going to figure out this determinant. 3 times negative 4 is negative 12. 4 times 2 is 8, so you subtract 8. And that will give you negative 20. That is your numerator for x. So put negative 20 over negative 10. And look, this simplifies nice to 2. All right, let's go for y now. Numerator for y. All right, you're going to take this matrix again, but since you're going for y, you're going to replace the y numbers here, y coefficients, with 3 and 4, your constants. So keep your 1 and 3, your x coefficients. Oops. And then 3 and 4. Now find the determinant. So 1 times 4 is 4. Minus 3 times 3 is 9. 4 minus 9, negative 5. That is your numerator for y. So now look, you put that over negative 10 now. This isn't divided to give you a whole number. Sometimes you get numbers less than 1 or decimals or fractions. Negatives will cancel. 5 over 10 is a half. So if you want to keep it as a nice 1/2, you can. So there you go, guys. X is 2, y is a half. You will get fractions occasionally. That's okay. All right. I don't think you get any crazy numbers or decimals, but you'll get fractions here and there. So 2 1/2 is your answer. Write it as a point. And there you go. All right, guys. That's how you use Cramer's rule. Follow the problems that I give you in the assignment today, just like this, and you'll be good to go. Show your work. Full credit. All right, guys. Have a good rest of your day. Talk to you later.